How does a hypervisor emulate virtual machine hardware? Imagine running multiple computers inside one physical machine, each acting like it has its own hardware. That's what a hypervisor does. It creates a layer that makes virtual machines think they have dedicated hardware. This layer manages the physical resources like the processor, memory, storage, and network interfaces. It divides these resources among the virtual machines, so each one can run its own operating system as if it had its own physical hardware. The hypervisor intercepts instructions from the guest operating system that need to access hardware directly. When the guest OS asks to do something like manage memory or communicate over the network, the hypervisor steps in. It either executes these instructions directly on the physical hardware or emulates the hardware's response in software. This way, the guest OS runs as if it controls real hardware, even though the hypervisor is managing everything behind the scenes. There are two main types of hypervisors. The first is called a bare metal hypervisor. It runs directly on the physical hardware of the host machine. It has direct access to the hardware, which makes it fast and stable. Examples include VMware ESXi and Microsoft Hyper-V. These hypervisors split the hardware resources among virtual machines with minimal delay. The second type is called a hosted hypervisor. It runs on top of an existing operating system like Windows or Linux. It relies on the host OS to access hardware and provide virtualization services. These are often used for testing or running virtual machines on personal computers because they are more flexible but slightly slower. The hypervisor emulates hardware in several ways. For CPU virtualization, it uses special hardware features like Intel virtualization technology or AMD virtualization. These features allow the hypervisor to run guest code directly on the processor while keeping it controlled. When the guest OS executes privileged instructions, the hypervisor traps these calls and emulates what the hardware would do. For memory virtualization, the hypervisor manages how guest virtual addresses map to actual physical memory. It uses techniques like shadow page, tables, or nested paging to keep track of these mappings efficiently. For device emulation, the hypervisor creates virtual devices that mimic real hardware, like network cards or storage controllers. Sometimes it fully emulates the hardware in software, which can be slower but more compatible. Other times it uses synthetic drivers that communicate directly with the hypervisor for better performance. Input and output operations are also managed by the hypervisor, which intercepts these operations from the guest OS and routes them to either real physical devices or virtual ones. This setup keeps each virtual machine isolated from the others while sharing the same physical resources. All of this allows multiple operating systems to run simultaneously on one physical machine. It makes it possible to run older software, test different operating systems, or create cloud environments efficiently. The hypervisor's ability to emulate hardware is what makes virtualization so flexible and powerful. It extends the capabilities of operating systems by allowing them to operate in a virtual environment, making hardware management more dynamic and adaptable.